Okay, so now for the next review, which is deals with roller coasters. Um, the first question says, as the bus you're riding in makes a sharp turn to the left, you find yourself pressed against the person to your right. The net force you are experiencing as the bus turns left points to your left, forward towards your right, about halfway between forward and towards your right. Now, again, these sorts of problems, you're always best to look at it from have an out-of-body experience and sort of view yourself from above. And so the idea is if you have a bus here, which is suddenly making a turn to the left, what you know is that if you're sitting in the bus, then you have to have in order to stay in the bus, you have to have a centripetal acceleration, which is towards the center of the turn. That means that there has to be a net force on you also in that direction. The reason why you feel yourself being pushed to the right is just because of your inertia. And so the net force on you has to be towards the left. Clearly it's not forward, and it's certainly not towards your right. So let's go to the next one. The second problem says, as you're riding an elevator, you sometimes feel heavier than normal. Two occasions when you feel more than your normal weight are at the start of a trip downward and at the start of a trip upward. At the end of a trip downward and at the start of a trip upward. At the start of a trip downward and at the end of a trip upward, at the end of a trip downward and the start of a trip upward. And again, these sorts of things, as if you're standing in an elevator, imagine that you're standing on a bathroom scale. So you're standing, on the scale itself. And the idea is imagine that you get into the elevator and it suddenly accelerates upwards. You still have your weight downwards, and the reason why you accelerate upwards is that there has to be a supporting force from the scale, which is in the upward direction. So your scale would read more than that. So clearly it happens when you're first starting up, accelerating, going upwards. So it would certainly be start of a trip upward. Obviously, so you're going at a constant speed. If you were coming close to your destination, then the acceleration would have to flip over, and so in order to come to a stop. And so on the way, when it comes to a stop, when you get up to the upward floor, this is when your acceleration would have to be less, and so you'd feel yourself being light. So clearly, it's at the start of a trip upward. And so start of a trip upward. That immediately allows you to eliminate this items 3 and 4. And so when would you feel yourself also being heavy? At the start of a trip downwards, right, the elevator car is going downwards, you feel yourself light. And so the point is that you only feel yourself being heavy when it's come to a deacceleration, because at that point, then the acceleration is back upwards again, and so again your spring scale has to apply a larger force, and so the end of a trip downwards would also work, and so it has to be number 2. Alright, let's do the next one. 3. You go through a loop in a roller coaster at a constant speed. Where is your apparent weight a maximum? So again, imagine you're going through a loop-to-loop, and so the car is going down here. You feel your weight at maximum when, clearly, when the car is at the bottom here going upwards. Because the point is that there has to be a net centripetal acceleration upwards. Your weight is absolutely in the wrong direction. And so the only thing that will work is that the normal force has to be quite substantial. If you were standing in a bathroom scale, for example, then it would read a significantly heavy weight at this point. On the other hand, at the top, your weight actually helps you, right? Because at the top, the centripetal acceleration is towards the center downwards. And so the weight's in the appropriate direction, so you don't need much normal force in order to provide that acceleration. So clearly, the only thing that happens is at the bottom. Fourth one. As you ride on a merry-go-round, you feel a strong outward pull that feels like the force of gravity. This fictitious force occurs because your velocity is towards the center of the merry-go-round, and you experience a fictitious force in the direction opposite your velocity. You are accelerating away from the center of the merry-go-round and experience a fictitious force in the direction of your acceleration. You are accelerating towards the center of the merry-go-round, and you experience a fictitious force in the direction opposite your acceleration, or your velocity. Now, the point is that you're either talking about the acceleration or the velocity. And again, the idea is that as you're on the merry-go-round and so it's rotating, then in order to keep you moving there's a centripetal acceleration at that point. And you always feel a weight effectively on you, which is in the opposite direction of the acceleration. So you clearly are accelerating towards the center. This is the real acceleration if you're looking at it from the outside. And so it's either towards the center here or the velocity is towards the center. Anything else, accelerating is away from the center, velocity is away from the center. But really, the fact that it's the acceleration that's required in order to give you that fictitious force, this is the only thing that really matters, which is the third one. Okay, number 5. If you're riding a roller coaster and want to minimize your feeling of weightlessness during the ride over the hills, where is the best place to sit? And so, again, the idea is that as you go over the lift hill, so you're in a car that's going over the lift hill, then in order to go in that circle, the centripetal acceleration is downwards. And so as a result, it's like when you're going over a peak of a hill in a car, is you feel the bottom drop out on you. And so the point is that since the centripetal acceleration varies as the velocity squared over r, the larger that velocity is, then the larger the centripetal acceleration, and the more you feel yourself being kind of weightless. So the point is if you want to minimize that, typically what you want to do is to minimize the velocity, and that only occurs really for the front of the car. Because essentially at this point then the cars are acting to drag you backwards. Where on the other hand, when you get over the top of the lift hill, then you've got this stream of cars which is pulling you down the hill, and you're going faster and faster as you go over the top. And so the last car that goes over basically has the largest velocity, meaning the largest centripetal acceleration. So if you want to minimize that, it's best to sit in the first car. The last car will give you the maximum effect. Number 6. The tumble dryer in the laundry room spins its drum about a horizontal axis. The clothes in the drum rise part of the way up to the side of the drum as it turns and then fall back towards the bottom of the drum over and over and over again. If the drum turned too fast, this tumbling effect wouldn't work. So in other words, if you have a drum like this, and so you have clothes that are stuck to the wall, as it goes up, eventually what will happen is like having a Hot Wheels track that doesn't have enough velocity, so that basically it will start coming back down again. This is what gives you the tumbling. But if it goes too fast, then it's like during the spin cycle of a washing machine. And so the point is that the clothes inertia would keep them pressed against the drum as it spun. So if it was going really fast, then the clothes would be sort of stuck to the outside of the drum as it rotated really at a high rate of speed. That's mainly because, again, the inertia wants it to go in along the same direction. And so it's their inertia that's actually doing that. They don't become weightless, and they certainly aren't accelerating upwards at the top of the drum, because at the top of the drum, the centripetal acceleration is downwards, so you can eliminate that. Clothes don't ever become weightless, right? They always have that attraction to the earth. And so it's only the mass, their inertia, that keeps them pressed against it. So this ends sort of the discussion about these 6 problems on roller coasters.